Okay, so that's a nice little review of the transformations that we did last class. Today, and like I told you last class, we're going to be writing equations, but this time we're going to be writing equations that are a little bit more complicated. All of the same rules apply. So if you would like to have the 2 pages from last class out in front of you, with the pictures and the table things, those are going to be very helpful, because today we're going to be not only writing equations of functions, we're going to be taking them not from the parent function, but we're going to be taking them from some other transformation. So right now, instead of starting with the parent function, the very first function we're starting with is this function right here. Everybody underline that function. That's our starting graph. Instead of the parent function, we're starting from some other graph. These are the more complicated problems. But all we want to do is translate it down 3. How do I translate something down 3? Where do I put a number to translate it down? On the outside. Is it going to be added or subtracted? Subtracted. So if we remember our steps from last time, our steps to write an equation said, write in function notation. So we're going to say, okay, g of x is just going to be f of x, and then I'm going to subtract 3, because that's down 3. Now, once we have it written in function notation, our second step was to plug the stuff back in. Last time, we only plugged in the absolute value. This time, you're plugging in that underlined equation. So here's what I'm going to do. I'm going to say, instead of f of x, I'm going to say 2x plus 1. That was the original function. And 2x plus 1 minus 3. Okay, I'm going to go ahead and erase these parentheses. It's important to see it, but just because I think you don't see things within parentheses. Do you see 2 things that I can simplify? Do you see any like terms? Yeah, which ones? The 1 and the negative 3. Those are like terms. Those are just like straight up regular numbers. There's no x attached to them. So I'm going to simplify them. 2x plus, and then 1 minus 3, that's negative 2. So this is my function that I think has taken the original graph and has moved it down 3. But we want a way to be able to check this work, because this is a little bit more complicated than it was last time. Now, last year in Desmos, what you would have done is you would have typed this into Desmos, and you'd have typed your answer into Desmos, and you would have just seen if it moved down 3. We're going to be doing the same thing. However, we're going to be doing that in the calculator. And I know it's been a minute since you probably did anything in a calculator. So first things first, do you remember how to clear it? What are the buttons to clear the calculator? Second plus 712. Very good. Anytime you pick it up, you should reset it, because first of all, the class I teach before you is pre-cal, so who knows what settings we've turned on for them. To graph something in this calculator, you click this button right here that says y equals. Do you see it? All of the graphing buttons are up at the top, so that's the start of the graphing buttons. You click y equals, and it's like, sure, what would you like to type in? Well, we want to type in the function they gave us at first, which was 2. This button is x, by the way, next to alpha. This one right here is always x. 2x plus 1. Okay. And then I want to go down to the next line, like I was using Desmos, and I want to type in our final answer. Our final answer was 2x minus 2. All right, once we've got our equations looking like this, we just want to check our work. But it's kind of hard to tell the difference between 2 graphs. So what we're going to do is we're going to make the second line bolder. You don't have to do this part. This just makes it easier. So I'm going to click the right arrow until the little flashy thing is all the way to the side. Can you move yours there? If you click enter once, it changes that little line to a thick line. I like personally doing this because I like seeing the difference between the 2 lines, because this doesn't graph in color. You know, on Desmos it'd be like, here's the red one, here's the blue one, so we could obviously tell them apart. This doesn't do that because it's an old piece of technology, so we're going to make it bolder. This is how you do it. And then we're going to see what it looks like. We press the word graph, and we're going to see. So my original function was the thin-lined one. My new one is the thick. Did it move down 3? Wait, you can't tell on here? Well, so here's the thing. It is an older piece of technology. It's not as easy to count, which is why we've liked Desmos for so long, but you will need to know how to use this. So if you're like, ooh, I really can't tell if that's 3, zoom in. So you press zoom. Option 2 is zoom in. Nothing happens at first until you press enter one more time. There, we move down 1, 2, 3. From the thin line to the thick line, we move down 3. Okay, sometimes it's helpful to zoom in just because, like, you know, it's got pixels. It can only do so much. The nicer, newer versions of these that you can buy for yourself, they're called Inspires. They are in color, and they have a little bit better pixels because we've updated our ability to do technology since then. Okay, so we know we got this question right because we watched it translate down 3. Let's do the next one together. This time, we're still starting from that same original function that we had in example 1, which is not a parent function, so that's important. It's not one of the original 3 that we've studied so far. But we want to translate it left 2 units. How do I move something left?
You place it inside the parentheses.
Yes, inside the parentheses. Now for left, am I going to add a number or subtract a number? Add, very good. So to the left is adding. So here's how we do this. We say g of x, that's the new function, is going to be the old function, but inside I'm going to add 2. Now I put it inside the parentheses on purpose. Okay, that was function notation. When we substitute the formula back in, anywhere there was an x, now you're going to put x plus 2. Okay, which is different than what we did before. Because now when I go to that last step, which asks me to simplify, I can't just straight up add 2 plus 1 because I've got this 2 sitting in front of the parentheses. What do we do with anything that's in front of parentheses, any number? Multiply. It technically starts with a D. What's that word? That is multiplying. It's like little arrows that do this. Does anyone remember that that's called? Distribution. It is multiplication. Distribution is multiplication. That's technically what it's called. Whatever. It doesn't matter. We're going to multiply. 2 times x is 2x. 2 times 2 is 4. And then I have this 1 that I brought down at the end. Is there something else I can simplify?
The 4 and the 1.
The 4 and the 1 are just straight up regular numbers. So let's add those together. That means that's going to be 5. So my final function here that I think the right answer is g of x equal to 2x plus 5. I'm doing exactly what I did last time, but it's just a little bit more complicated. So I've taught you nothing new. These are the same steps as last time. We're just adding in a little bit more algebra skills when it comes to the simplify step and where we're plugging it in. But again, we want to check on our calculator. Okay, so it's the same steps like last time. The only thing extra I've added is the simplify step. We just didn't need it last time, but it's the same steps. Do we have questions before we move on to the inside of this? No, we're good? Okay. Let's roll to the back side, or the inside, I guess I should call it. So this time, we're starting from this weird looking function. What type of function is this? Is it linear, quadratic, or absolute value?
Absolute value.
Very good. So it should look like a V. We know this because of literally the bars there. Those are called absolute value bars, so we use the bars. And we want to do what to this one? We want to reflect it in the x-axis. Look at your charts. How do I, put a minus sign where? In the very front. So let's do that. We say the new function, g of x, is going to be the old function if we put a minus sign in the very front. That's it. Great. Now it's just a good amount of simplification. So let's plug all of that in. We started with a minus sign in the very front, and then we plug in the entire function. That means I'm plugging in absolute value of x plus 3 plus 1. The whole thing. The whole thing is named f of x. I plug the whole thing in. This time the parentheses are important because now I have this number 1, or -1, sorry, in front of a parentheses. I still have to do this. Distribute, distribute. Now that is going to be distributed just to the front of the absolute value. Don't go inside the absolute value bars. You can't do that. No going inside the absolute value bars. Okay? So this ends up simplifying to negative absolute value of x plus 3, and then negative times positive is -1. Okay, again, all I've done is basically distributed a -1 to everything, but it doesn't go inside the absolute value bars, not allowed. Just chills right in front of it. All of the signs are changed. Now let's check that in our calculator. And this one for sure I'm having you check in your calculator because the absolute value function, we have to go find. So follow along with me. I'll go slow on this one. On y equals, we clear out what we had there. I don't want that anymore. And we're going to type in what we started with. We started with absolute value. Everybody click math. Math is right here. You're going to go to the number screen. So that's to the right. ABS. What do you think ABS stands for? Absolute value. I will do it again. I'll do it again. Okay, and boom, the bars are there. Okay, so if you got lost, let me do it again. We clear out what we had. We press math. We go over to number. And that first option says absolute value. Now it puts the bars there for you so we know what it should look like. Now this says x plus 3 on the inside, and then I need to scoot outside of it. So I click the over button, plus 1. And we think that our final answer should be negative absolute value. So I got to go do that buttons again. Math, number, ABS, x plus 3, thank you, Ruby, minus 1. Maya, do you have a pass? Okay, thank you. Okay. Pause, check on your neighbor. Did they find the absolute value bars? And like legit check on them. Did you find it? Find it? Yes, sir.
Take off this number so I can put it on the other side of the board.
Ah, yes. Okay, so the little flashy thing, you're going to put it on top of the number you want to delete and press delete, D-E-L.
Oh, okay.
And then you want to delete that 3, 2, and then you can go outside.
Oh,
You're welcome. Let me see if I'm charged up enough. So we've checked it in our calculator. It visually looks like it flipped all the way over. Awesome. Let's keep going. The next question wants me to reflect it in the y-axis. Same parent function I had just a second ago. So we're just taking that same absolute value function, but this time we're going to reflect it in the y. How do I reflect something in the y-axis? There's a negative somewhere. Where does it go? In the inside, literally right next to the x. So here's how we do this. We're going to say g of x is equal to the original function, except that I'm plugging in a negative x this time. That's going to reflect it in my y. So whatever is inside that little parentheses for f of x, which is now f of negative x, that's what you plug in too. So this is going to be absolute value of negative x plus 3 plus 1. I've just substituted in this negative x right there. That's all that the stuff inside means. Just put that in there instead. Okay. Is there anything I can simplify? Are there some regular numbers I can add together? Are there some distributions I need to do? Anything like that? Hopefully your brain's thinking no, because this is actually already simplified. Okay, but again, we want to visually check and make sure that it actually reflected in the y-axis, because there's no visual change for the parent function. This one's going to have some visual change. So I'm not going to lead you through checking it. I want you to try it. That way, if you forgot where a button is, now's the time to realize we forgot and you can ask questions. Okay, let's keep going. Are we starting to see kind of how this works when we're writing them? It's a more challenging version of transformations than we've done, but we can do it. For example 5, we are taking this original function, this f of x, its absolute value. Oh, I'm not showing you what I'm doing because I'm showing you the calculator. Absolute value function, and we're going to vertically stretch it by a factor of 2. So vertically stretching something. How do I do that? Does the 2 go inside or outside? Outside. It's a vertical direction. Yeah, I know your paper says it. It's a vertical direction, so it's outside. And when we're vertically stretching or shrinking or horizontally stretching and shrinking, we're going to be multiplying. So that number is going to be multiplied in the very, very front. That's what the pattern says. And I use the exact same number. I don't have to use a flipped version of it. So I'm going to take g of x. I'm going to put this 2 in the very front and then substitute in f of x in a second. Because I'm vertically stretching it by a factor of 2. That means the 2 is multiplied in the front. So when I substitute in f of x, this is going to be 2 times the absolute value of x minus 3 minus 5. All of it in parentheses because it's outside. So we make sure it's all in parentheses. This time, do we have something to simplify? Yes. That 2 is in front of a set of parentheses. What do we do with it? Multiply. We distribute it. Very good. So we're going to distribute it twice. Remember, it cannot go inside this absolute value bars. It's just going to go right in front of it. So we're going to do this. Multiply, multiply. This will end up being 2 times the absolute value of x minus 3 times negative 10. I have to multiply that. Just like I had to do for the minus sign, I have to do that for the 2. So I have one step of simplification. But remember, it does not go inside the bars. Okay, let's visually check. I know it's like every single time you're turning to that calculator and you're checking again, but yes, we should do that. And when you get at home and you don't have a calculator, obviously you'll know how to do this on Desmos because it's the same / easier. So let's go for the calculator. Let's keep going. Now that you know how to check it, I'm going to kind of bypass the checking on this last one, but you know how to check it visually now. So you should be able to do that every single time. This time, we want to take this parent function, or I guess it's not a parent function, but this original function, and we want to horizontally shrink it by 1/3. Now, hopefully your spidey senses are tingling. A horizontal shrink by 1/3. I am not going to be plugging in the number 1/3. What number am I going to be plugging in? 3/1. Very good. So remember, horizontal stretches and shrinks, I take the number they tell me and I flip it over. So this time, instead of 1/3, I'm going to use its reciprocal or its opposite, and the number I'm plugging in is 3. Okay. Phew, got that out of the way. Now we take g of x and we say, all right, to horizontally stretch this, or sorry, shrink this, I'm going to take on the inside and put 3x. Because horizontal is inside. Vertical is outside, horizontal is inside. Cool, no big deal. We're going to go ahead and substitute that in. That means anywhere in the original function I saw an x, now I'm putting 3x. Is there anything I can add, subtract, multiply together? No, because you can't add and subtract things from outside and inside the absolute value bars, so I'm actually done. Okay, now again, I'm just going to bypass the checking step on this one. We've done it enough, and you know that that's there for you, and you're going to be checking in a little bit with your partner. Okay, but here's where it can get here's where it's going to get a little bit challenging. Kind of like the end of your Desmos slides last time. We are now going to be taking multiple transformations at the same time. And we're going to be doing them at the same time. You did this last time in the Desmos slides, but you did it from a visual graph. This time we're going to be doing it from words. Now the first thing we're going to do is we're going to number the transformations in the order that they occur. So we need to do them in the order they tell me. You can't pick your favorites and do those first. You have to do them in the correct order, which is kind of annoying, but that's how we're going to do it. Okay. After we number the transformations, like 1 through 3 or 4, you're going to take the first transformation and do the steps that we've been doing. So we're going to be doing the steps, again, that we did on the other page multiple times. And then we're going to repeat the transformation process until we get through all of the things it tells me to do. So in example 7, it says to take this function and I want to, number 1, translate it up 2 units. That's the first thing I'm going to do. Number 2, I'm going to vertically shrink it by a half. I have to do them in this order. I can't pick and choose. And then number 3, I'm going to reflect it in the x-axis. That is the order I have to do it. I can't pick and choose which one I do first because they said to do this, this, then this. Okay. But we go step by step. To translate something up 2 units, all that means is I'm going to take the original function and I'm going to go up 2. So we substitute in absolute value of x because that's the function that we're using this time. And I'm going to add 2. No sort of simplifying needed for this one, but I'm done with the first step. I have done translating it up 2. The second thing says to vertically shrink it by 1/2. To vertically shrink something, I'm going to put a 1/2 on the outside in the front like it's multiplied. That's the pattern for vertical shrinks, is that that number just gets put in front. So again, if this is helpful, so far I have added 2 to translate it up, and this time I'm going to multiply by 1/2 to shrink it. Okay, we substitute in like we are used to. That means there's a 1/2 in front, and then I plug the new function in. But the function I'm working with now is absolute value of x plus 2, not the original, this one from step 1. Almost. So step 2, we have to clean it up, so we do have to do some distribution because this one has a step for simplification. But it's just multiplying everything by 1/2, which would make it 1/2 absolute value of x plus 1, because 1/2 times 1 is, sorry, 1/2 times 2 is 1. That's the end of the second transformation. So I'm just doing the same thing multiple times. This is what we did on all the other examples, but it's all for one problem. The last thing it tells me to do is to reflect it in the x-axis, which means that negative sign goes in the very front of the function that I'm using. But remember, it's going to be this one that we just paused on. Which means there's a negative in front of a set of parentheses, and I have 1/2 absolute value of x plus 1. That's the function I just had. That's where I'm getting it from. Is there a step to simplify this one? I've got to distribute this little negative sign. So I'm going to multiply, multiply. Remember, not inside the absolute value bars, just right in front of it. This would end up being negative 1/2 absolute value of x minus 1. We took the original function. We translated it up 2. That was the first part that we did. And then we shrank it by 1/2. And then we reflected it. In that order creates this transformed graph. If you did it in any other order, you might get a different answer. So order matters. The order that they tell you to do it, you do it. Okay? These last few where it's multiple transformations are a little bit more confusing, but that's why we led it up to it. It's the same steps, just multiple times for the same problem instead of different problems. Okay, let's put all of this together into one visual aid, because on the last notes I had 2 little visual aids for you, and that might be much to look at. So go to this page that looks like this. It's like a half sheet. Here is all of your transformations put together into one document with Voss and Hayo written there. Vertical outside same, horizontal inside opposite. Now there's a transformation that can occur right here. If this little blank spot has a negative sign in it. That right there is going to cause a reflection in the x-axis. So when you look at an equation, you just look at the very front. If it's negative, it's reflected. If there's a number right here in front of the absolute value bars, that number makes a vertical stretch or shrink. It's going to stretch if the number that is right there is bigger than 1, or a big number. And it's going to shrink if that number is between 0 and 1, or is a fraction. So if you want to write big number, fraction, whatever works for you, these are your notes. There's an opportunity for a number to be multiplied here in front of the x, but inside the function. Since it's inside, we know it's horizontal. It's going to create either my horizontal stretches or my horizontal shrinks. But the number is opposite. If it's a fraction, it stretches. If it's a whole number bigger than 1, it shrinks. Opposite. I guess I should use the letter B since that's the letter that we used here. Sometimes notes will say A and sometimes they'll say B, just to make it a different number. Inside those absolute value bars, if you have a number that is added or subtracted behind x, those numbers are going to be your horizontal translations. Translation just means slide. And if you see a minus a number, it's going to go to the right. If you see plus a number, it's going to go to the left. Then last but not least, the last transformation we've learned about is adding or subtracting numbers at the end. What does that one do? That's going to move my graph up or down, which is called a vertical translation. If you see plus some number, it's going to go up. If you see minus some number, it's going to go down. Okay, I wanted to give you the most number of resources to look at. Maybe this, having it all on one page, is a bit easier for you than the 2 pages we had last time. And maybe you're like, honestly, Miss Q, the 2 pages in the chart from last time was the best one. That's fine. They're your notes. I just want to make sure you have all the opportunities to understand what these numbers do in these equations. Because they do a lot. They change it all up.